So in this equation, you can see that these two equations can be brought out in matrix format, and the matrix format for these two equations is that I am subjecting this R and L to separate matrix. So if I write them in matrix format, I'll be getting this equation. I'll take this as V is equal to I into Z. So to obtain Z, what I must do, Z is equal to I inverse into V, right? So that's why this is Z matrix, this is I inverse, and this is V matrix. Okay, you can go with solving problems on this one. Once you determine this R and L individually, then Z is calculated based upon R plus J omega L, where omega is nothing but your 2 pi F. F is nothing but your signal frequency. Okay, once you get this value of Z, Z will be compared with your setting value, and if it is low, then the relay will be giving a trip signal. So from the above equations, the values of resistance and inductance can be obtained, and from that Z can be obtained, and it can be compared with a preset value in order to issue a signal. Now, if you carefully see how many samples you do require n minus 1 sample, you do require n sample, you do require n plus 1 sample, and you do require n plus 2 sample, which means that you do require a minimum of 4 samples to perform this technique. See, a window of 4 samples is seen to be adequate for computing one estimate values of R and L. In order to make this method more robust, the window can be shifted further and another can be made. You can take 4 more samples of a separate window and then you can calculate and compare it. Now, let us try a problem on this one. See, this is your differential equation method. The voltage and current signal having 50 Hz fundamental frequency, they are sampled at, this is a sampling frequency, and determine the impedance using differential equation method. See, this is the data which has been given for us. We do have 8 samples of data, and among this I am considering only 4 samples, because in differential equation method I do require only 4 samples. I'll take this as n, this will become n minus 1, this will become n plus 1, and this will become n plus 2. Once I do have these samples, these represent the I current samples, these refer to voltage samples. Now to obtain the impedance, I will utilize this particular equation. See, I'll write here, this is IN is 3.977, this is IN plus 1, it is 4.83, into here, this is I dash, right? So I dash I will calculate here, IN plus 1 minus IN minus 1 by 2 delta t. How is delta t obtained? Delta t is 1 by sampling frequency, 1 by 800, it is 0.00125. Okay, so if I take this one, this is IN plus 1, it is 4.83 minus, this is 2.5 by 2 into 0.00125. So if I do it, I'll be getting 2.33 into 400, it is 12, so it is 932. Similarly, I double dash, if I do it, it is IN plus 2, sorry, this is IN dash, this is IN plus 1 dash, okay. IN plus 2 minus IN by 2 double delta t, so it is 4.96 minus 3.977 by 2 delta t. So if I use the calc here, so it is 393.2. Okay, so it is 393.2. Now I am substituting these values here. This is 932, this is 393.2, and Vn sample is this one. This is Vn plus 1. So it is 115.46, this is 125. This is inverse is there. Now what is the inverse of this one? If I take, this is A, B, C, D. You know the inverse of the 2 by 2 matrix. It is 1 by AD minus BC into D minus B minus C A, right? So let us rewrite this equation again here. This is my R, L. This is my 3.977. This is 4.83 and 932, 393.2, and this is 115.46, and this is 125, and this is inverse of this one. So if I take, this is 1 by 3.977 into 393.2 minus 932 into 4.83 into D minus B minus C and A into this matrix. So if I do this one, I will be getting 3.977 into 393.2 minus 932 into 4.83. It is minus 2937. So it is minus 2937 points something, right? So this is multiplication. So I'll get it as just 8. I'll write it as 8 here. Okay. So this is 393.2 into 115.46 minus 932 into 125. It is 71,101. It is minus 71,101 point something 68, right? Now the other one, sorry, it is 128. Now the other one, minus 4.83, sorry, minus 4.83 into 115.46 minus 932 into 12 and 25. So minus 4.83 into 115.46 plus 3.977 into 12.5. I think I'm doing a mistake here. Minus 4.83 into 115.46 plus 3.977 into 125. It is minus 60.5. It is minus 60.54, right? Now, if I do the calculation here, now this one, 71,101.128 by 2937.8. So this is your resistance, 24.202. Whereas this is your inductance. How much it is? 60.54 by 2937.8. 0.0206. Okay, so this is your R value, this is our L value. So R is equal to 24.202, L is equal to 0.0206. This is Henry, this is ohms. Now if you want Z, R plus J omega L, R is 24.208 plus J, it is 314 into 0.0206. So I'll get 24.2 plus J .47. This is my house. Now you can convert it into complex component if you want in polar format. So in order to obtain the magnitude and also phase angle. Once you get the value of Z, you should compare it with your preset value. If it is less than your preset value, then automatically you can issue a signal. Okay, so I hope that now you have understood how to determine the impedance from given samples of voltage and currents. Okay, so coming to the conclusion, the differential equation method is a technique which is used for implementing numerical distance protection. It involves solving differential equations and it can provide accurate and reliable fault detection. And if you carefully model the transmission line and if you carefully select the relay settings, you can effectively apply this differential equation method for numerical distance protection of transmission lines. So I hope that now you are able to determine the impedance of the transmission line using the differential equation methods. Thank you. We will discuss more problems in the class.